Wild here again. I've got my secondary transformer here, my bifilar wound secondary, disconnected entirely. So the only thing connected right now is my new triple wound, opposite wound inductor of my previous video. So that's it, just the opposite wound inductors. Look at that waveform. We're at 134 volts starting out. Definitely appropriate production for the voltage level of 130. Only still less than 300 milliamps across the cell, but that waveform is a nice waveform, equal opposite polarity pulses. We're consuming 7 amps though, but it's wild that just those inductors are causing all that. Something to do here a little further. I'm at 1.62 kilohertz, 64% duty cycle. See what we can do.
This is Stan's Revenge.
This is my cell at idle right now. Active idle. Waveform. Consumption. Voltage. Amperage across the cell. Appropriate production. But what I want to show you here is to get this waveform at 115 volts or so. I have no secondary connected. Right now I simply have my primary, which is a different primary from my other coil, whatever I did with it here. Nonetheless, my same triple wound inductor, opposite wound, and where the secondary winding should connect here, I just have it bridged with a wire. So there is no secondary coil, it's just connecting the two inductors together. And yeah, so with no secondary, I get a good waveform over 115 volts at the cell and appropriate production without the secondary. Question being, that's just about the same performance as I get with the secondary hooked up and everything. So the question is, why do I even have a secondary? What relationship does the secondary have to the inductor by means that I can get appropriate production just connecting the circuit rather than having a secondary bifilar wound coil there? And I'm like, is my secondary too big? Does it just need to be a few reps to isolate the windings? And is it the inductor that needs to be the largest part of this equation? So maybe we have it all wrong. We're trying to step up the voltage high at the secondary and choke it with a small inductor, whereas maybe we need a small secondary, a small step up of, let's say, just enough voltage to power the system, whereas the inductors need to be twice as big, 3 times, 10 times as big, who knows? But the magic is in the inductors, and especially being a opposite wind like that gives us the waveform we need. I want to do maybe a test here and check out what my bifilar coils do by themselves and what waveform they produce, equal, opposite, etc. Compare that to the opposite winding. But my thoughts of today is that, I'm trying to step it up a lot on the secondary, when in all reality the magic happens on the inductors. We only need to isolate the primary input to the secondary in a small step-up voltage. It doesn't have to be thousands of volts. It can be maybe just a few hundred volts to have enough pressure to you know, energize the coils on this side. The inductors is what is important. That's where the charge is stored. I believe we just need bigger inductors, smaller secondary. We're going to maybe do some more winding and some tests here. But that's my findings. Also, I want to point out, and I've noticed this on many different configurations here, and watch the voltage here. It's currently depleting. Watch the voltage. When I turn it on directly, we have a initial voltage of 120 volts or more, and then it slowly comes down to about 115. Watch, ready to go. It's 119 volts. And you can see it comes down, comes down, comes down. And it'll settle down about 115 volts. Turn it off again. $117 volts. What I want to point out is that by gating the set of pulses, so we have a set of pulses, brant, off, brant, set of pulses, rather than just a continuous stream brant, of pulses, aids in the maximum voltage of the cells, as per Stan Meyer's memos. So you can see in that graph, which I might link up here, shows that, you know, we have the frequency here, duty pulse, then we have the gated duty pulses that basically translate to a higher voltage level in the cell, which by this would make sense because we have the highest initial voltage right there at the beginning, and then as current begins to flow, voltage drops. Makes sense.
This is Stan's Revenge.